Hi class, we have the 20th lesson for algebra. This is the second lesson for change of subject or formula. In each of these cases, we are to make the letter in the bracket the subject. So for the first problem, we want to make R the subject, this R. Here, we want to make G the subject. Here, we want to make X the subject. So one says V equal to 4 third by R cube. Alright, V is equal to 4 third by R cube. We want to make R the subject. As it stands now, um, R is not the only letter we have on the right hand side. Besides, it has a power of more than 1. So therefore, we cannot say R is the subject here. V, on the other hand, the power of V is 1, the coefficient is 1, and it is the only letter we have on the left hand side. The only thing, not just letter, the only thing we have on the left hand side. So therefore, V is the subject of the formula as it stands now. But we want to make R the subject. So making a letter the subject is the same as solve for that letter. So all the principles used to know in linear equations, quadratic equations, and simultaneous equations are the ones we apply here. So what we do is we say V is equal to 4 times pi r cube is 4 pi r cube over 3. We give this 1. 1 times 4 pi r cube is 4 pi r cube. V times 3, 3v. But it's R we want to make the subject. We want to make R the subject, meaning it is R we are finding. But what is in front of R is 4 pi. So we divide by 4 pi. 4 pi here. So 4 pi takes away 4 pi, leaving R cube. This is 3v over 4 pi. But one of the conditions in making a letter the subject is that it must not have a power other than 1. 1 is the only power we accept. 1 is the only coefficient we accept. And it must be the only thing you see you have on one side. So we've succeeded in having only R, nothing else here. And here is 1. But the only thing is R, the power must not be other than 1. It has to be only 1. So what we do is we ignore that power, but because it is 3, we take the cube root. It has to be inside, not outside. The cube root of 3v over 4 pi. The root must cover the denominator. So now you can see R is the only thing we have on the left. The power is 1, the coefficient of 1. So the coefficient is 1. So therefore, R is now the subject. We've made R the subject. The second one is T is equal to 2 pi the root of L over G. Yes, as it stands now, T is the subject of this formula. Yes, but what we want to do is we want to make G the subject. See, it is the one they put here. Make the letter in the bracket the subject. We want to make G the subject of this formula. So what do we do? Given T equal to 2 pi the root of L over G, you can see the root covers down to the bottom, the denominator. So we want to make G the subject. Well, first of all, G is in a root. At the same time, there is something immediately outside the root. Let us start by brushing this, by taking off this. So we divide both sides by 2 pi. Here again, 2 pi. So 2 pi takes away 2 pi. T over 2 pi equal to the root of L over G. All right, we want to make G. We want G to stand alone. But that we want to make the subject, it is in a square root. The only way to break square root is when we square it. For a square root to be eliminated, we need to square it. But this is an equation wherein whatsoever we do on one side must be done on the other side. So if here we square, here again we're supposed to square. So if this square affects t, we say t squared. If it affects 2, 2 squared, which is 4. If it affects pi, pi squared. So now no longer what? No longer have a root. L over g. But the question is, have we made g to stand alone on one side? No, because on the right hand side, it's not only g we have. We have g, we have L. So what do we do next? We are lucky that we have one term equals to one term. So we can cross multiply. G times t squared. G t squared. L times 4 pi squared. 4 pi squared L. Have we succeeded in making g stand alone? No. What is disturbing us now? It is the t squared. We don't want to see t squared here. We only want to see g. So we divide both sides by t squared. So this goes with this. So g is equal to 4 pi square L over t squared. So now you can see g is the subject of this formula. The power is 1, the coefficient is 1, and it is the only thing we have on the left hand side. So now g is the subject of this formula. So now the third one says y equal to 2x plus 3 all over x minus 4. This is the third one. We want to make x the subject. But as it stands now, y is the subject of this relation, of this equation, of this formula. Okay. So being that though this one is not a formula because it is not a template for us to solve certain problems. So we can only say this one is a relation or we say an equation. All right, so we want to make x the subject. The first thing we do is y, we give it 1, 2x plus 3 over x minus 4. So we say 1 times 2x plus 3 is 2x plus 3. This multiplies this, we say y into x minus 4. One mistake some students do, beginners, if they want to make x the subject, what they will do, they will say 2x is equal to y into x minus 4. We'll move this to the other side. Because they need x, we divide by 2. We divide by 2. So x is y into x minus 4 minus 3 over 2. This is the mistakes beginners do in change of subject. When you are making a letter the subject, that letter must not appear on the other side. How can you make x the subject when on the other side there is x? We don't do this in change of subject. This is a condition I don't want you to forget. So we cannot simply move 3 as if we've succeeded in moving the x terms. There is also x on the other side. So we say 2x plus 3. This times this is xy. This is minus 4y. What do we want? We want to make x the subject. We want x to stand alone. Pay attention what I'm doing here now. If we say 2x here, this moves here minus xy. Because if you want to make a letter the subject, the first thing you do, if you have more terms containing that letter as it happens here now, we want to make x the subject. There is x here, there is x here. What do? We collect all the terms containing that letter. So, but there is something I don't want you to be doing. I want to explain now. I'm explaining now. So 2x, we move this one here. Here is minus 4y. Yeah. This is correct actually in trying to collect all the terms containing x. But the thing is, mathematics, sometimes if there is a way to avoid the beginning to be minus, we always want to see that. But it doesn't mean that if you leave it this way, you will not be able to get the actual answer. But some people are not good at presenting things the way they should be in order to get what they desire in solving problems. So to avoid that, um, we the x terms can go to the right. Since the x term here is already plus, so now we say 3. This one comes here plus 4y. This is xy. This moves minus 2x. But the previous method I discouraged you from doing, there is also a way that will lead you to this. Yes, but it needs extra manipulation. So now you can see here is plus, the beginning is plus. And we've collected all the terms containing x that we want to make the subject. So 3 plus 4y. Now this and this, even if you have other value, that is the only difference you do. That is the only difference we have in change of subject from the normal equations, linear, quadratic, simultaneous. Which one is that? Even if um, let's say you have your y squared, even if y is common, x is common, you only factor the letter you are making the subject. Forget about y being common. I hope it is clear. Factorization, not only x that is common, also y. But because of you are trying to make x the subject, only factor what you are making the subject. That's your concern. Whenever a situation like that one arises. Okay. So now x is common. X takes away this, leaving y. This takes away this, leaving 2. We need x. So divide by y minus 2. Y minus 2. So x is now standing alone. So 3 plus 4y, y minus 2. So now we can see that originally y is the subject, but now x is the subject. It is the only thing we have on the left. Its power is 1, the coefficient is 1, so it is the subject. Thanks for watching. Don't forget to follow, like, share, and comment. See you in my next video.